You know, we all know the classic tropes, right? The red eyes, the dry mouth, the infamous munchies. But what is THC actually doing to your anatomy, down on a cellular level, to trigger all of that? Well, it's actually much more complex and honestly way more interesting than you might think.
So, here is our roadmap for today. First up, the endocannabinoid system. Then, we'll decode those classic side effects. Third, the anatomy of the munchies. And finally, we're going to examine tolerance, dependence, and addiction. Let's get into it.
Section 1. The endocannabinoid system. This is the foundational network that makes all of these reactions possible. Okay, so cannabinoids are basically these natural compounds found in the cannabis plant. And while there are literally over 100 known variations in there, the psychoactive THC and the mostly non-psychoactive CBD are the primary actors here. Their main job? They act like chemical keys, binding to specific receptors in your body's incredibly vast endocannabinoid system. And what's totally wild is just how widespread these receptors actually are inside of us. We've got two main types. First, CB1 receptors, which are heavily concentrated up in your brain and nervous system. And then CB2 receptors, which are found mostly in your immune system and peripheral tissues. Because these receptors are quite literally scattered everywhere, consuming THC doesn't just impact your head. It triggers a massive systemic reaction across your entire body. Which brings us to Section 2, decoding classic side effects. Let's tackle those famous physical tropes we mentioned earlier. For the longest time, people just explained away these side effects with a pretty simple assumption. Oh, it's just the hot smoke irritating your eyes and mouth. And I mean, it sounds logical, right? Hot air dries you out, makes your eyes water and turn red, but it turns out that is an absolute myth. And here's exactly where that smoke myth completely falls apart. When cannabis is smoked or vaped, sure, THC enters the bloodstream directly through the lungs and hits the brain in minutes. Edibles, on the other hand, take much longer because they have to process through the digestive tract and the liver. But here's the kicker. Edibles bypass smoke entirely, yet people still get red eyes and dry mouth. So, this proves these reactions are actually driven by an internal receptor response, not external smoke irritating your face. So how do the eyes actually get red then? Well, it's a fascinating physiological cascade. First, as THC enters the system, it basically tells your blood vessels to relax and dilate. And because those vessels widen, your overall blood pressure actually drops a bit. Finally, the tiny little capillaries supplying your eyes, which, by the way, contain a super high density of these receptors, they dilate as well. So, they end up holding more blood, making the eyes appear characteristically red. It's not irritation, it's a literal vascular pressure change. And the anatomy of dry mouth is just as incredible. Your salivary glands, like the really large parotid gland right beside your ear and the submandibular gland just below your jaw, normally produce lubricating saliva and digestive enzymes. But just like the eyes, these glands contain a massive density of cannabinoid receptors. So when THC binds directly to them, it physically downregulates or basically halts saliva production. Again, not hot air drying you out, your glands are literally receiving a direct chemical signal to hit the pause button. Section 3. Anatomy of the munchies, also known as the satiety override. Okay, to truly understand the munchies, we have to start right at the command center, the hypothalamus. It's this small but absolutely vital region of your brain that acts sort of like your body's thermostat. It maintains homeostasis by regulating your temperature, your hormones, and, crucially for our topic, your hunger. Inside that hypothalamus, you have these specialized POMC neurons, and they normally send a crystal clear signal to your body saying, hey, I'm full. But when THC enters the chat, it binds directly to the receptors on these neurons, actually altering the signaling right down to the mitochondria. This altered signaling triggers a huge release of endorphins that literally overrides your brain's full signal. THC basically flips your biological stop sign into a bright, flashing green light, vastly increasing your appetite. And honestly, that is exactly why an entire family-sized bag of chips can vanish so incredibly fast.
Section 4. Tolerance, dependence, and addiction. Now we need to objectively examine some of the long-term impacts.
You know, these three terms get mixed up constantly in casual conversation, so let's properly separate them. The first step on this staircase is tolerance. This is where receptors adapt to repeated exposure, meaning you just need more THC to get the exact same effect. The next step is dependence. Here the brain neurochemically adjusts to having regular THC, which means stopping suddenly requires a recalibration period. That's what causes withdrawal symptoms like anxiety or poor sleep. And finally, we have addiction, clinically known as cannabis use disorder. This is a behavioral pattern where use continues despite negative consequences, intense cravings, and a real disruption to daily life. It's a spectrum, guys, and it's important to note that dependence does not automatically mean addiction.
When we look at the actual population data specifically for adult onset use, roughly 10%, so about 1 in 10 adults who use cannabis will develop dependence or cannabis use disorder at some point in their lives. The vast majority, 90%, do not.
However, when that exposure happens earlier and cannabis use begins during adolescence, while the brain is still actively developing and rewiring itself, that risk actually jumps. It increases to roughly 16.6%, meaning about 1 in 6 individuals will develop dependence. So, early exposure to these structural neural circuits clearly plays a massive role.
And we see this data translating into real-world trends right now. Looking at the U.S. prevalence of cannabis use disorder for ages 12 and older, there's a pretty significant upward shift. In 2020, an estimated 14 million people met the criteria. But by 2023, that number actually rose to 19 million. Now, while that is still a minority of overall users, going from 14 to 19 million in just 3 years is undeniably a mathematically significant increase.
Now, to put this all into perspective, when comparing risks across different substances, cannabis definitely has a lower risk of addiction and dependence compared to things like nicotine, alcohol, or opioids. Its physical severity and overdose risks are also categorized as significantly lower. But the absolute crucial point to take away here is this: while cannabis falls lower on that severity spectrum, the risk is definitely not zero. THC is actively interacting with real, tangible neural circuits involved in reward and motivation, and biological adaptation absolutely does occur.
So what is the core takeaway from all this biology? It's that the endocannabinoid system evolved over millions of years to maintain a very, very delicate physiological balance. Repeatedly pushing this deeply ingrained system in one direction, especially with early exposure or modern high-potency products, inevitably leads to real structural adaptations within the body.
Which honestly leaves us with a pretty provocative final thought. With our endocannabinoid systems built for such a delicate internal balance, how will modern high-potency THC reshape human biology over the next century? It's a totally fascinating area of rapidly evolving science. Thank you so much for joining me on this explainer, and keep exploring the incredible biology happening inside of you every single